from the Y files.
Yeah. All right. And I need to share that. Okay, so the meeting is being recorded. Let me switch over to, let's see, share that one. And do I want to do audio? Okay, so everybody should be able to see. Well, let's see. It may take a moment here for it to get there. Come on. It says I'm sharing. Oops, let's see here.
Shows your screen or a window.
Come on. Sometimes this takes a little while to catch up. Optimize. Oh, disable, hide names. Why am I just seeing? I'm seeing Bob's face. Why am I not seeing my screen? Oh, there it comes. Okay, it just popped up over there. Something went wrong. Oh, close on. Well, that's weird. Well, it says I'm doing it, but maybe I'm. Is everybody seeing the SRS sign-on screen there? Okay. Okay, maybe we'll just go with this. I don't see it, but that's okay because I can see it on John's screen next to me here. So, all right. All right. Let me. So we're gonna just welcome everybody to the July meeting of the Seattle Robotics Society. If you're not already muted, but I think everybody else is except me. Maybe you want to mute me too. I don't know, but. We will follow our typical agenda here, and I'm not going to read through it. You guys probably, most of you are pretty familiar with that. And we will have a presentation in the latter half of the meeting here from my friend John, who's sitting next to me. So this is almost like an in-person presentation here, except the only person who's in person is with me. So microphone's muted, talked about that. If you have questions, throw them into the chat, and I'm going to get my chat window open here. So any information, if somebody throws out a link, whatever, just put it in the chat. That'll get captured and then posted with the meeting notes from this. And then I'll usually get an AI summary of the meetings as well. So I don't know how many of you have looked at those, but those actually are pretty cool. So it'll kind of capture and summarize what we talk about during the meeting. Okay, let's see. I'm one of three that's been hosting these meetings, and sometimes four. So I was able to do it this month. Sometimes I get other folks to step in and host these meetings. So usually Lloyd, Chaz, or myself, but Donna is also a fourth backup. Come on. There we go. I suspect that most of you have probably checked this out. If you've gone and visited the our merch store, you can get all kinds of cool things with SRS stuff imprinted on them, and I think seems like they're pretty reasonably priced, and they'll make it up for you and ship it off to you, and it's an option for getting more than just t-shirts. So you can get mugs, duffel bags, baseball hats, phone skins, whatever. So check it out. If you got a camera handy, you could snap that QR code and that'll take you right to it. There's also a link on the front page of the SRS website. On the left side, there's an information box that pops up, and that has a link to it. So feel free to visit that. I believe, unless somebody corrects me, I believe next Saturday there will be a Build It with Arduino session that's hosted by Donna in the afternoon from it'll be 1 to 3 your time or Pacific time, and so you're welcome to join that. And I think this month is going to be checking on the status of the construction or the conversion of an RC vehicle to Arduino control. So taking a sort of a standard off-the-shelf kind of kit and then removing the RC control of it and converting that to a Arduino control, which is that sounds like kind of a fun project. So anyway, she has a meetup that has the details for that, and then there's also a YouTube channel with videos from previous meetings. So you're welcome to check on that and rewatch those or watch them if you haven't been to the meetings. Robothon. I will allow, since Lloyd's here, I will let him speak to this in any way he would like. So,
Okay. So yeah, as Steve has there, we're going to do our fall event on. Come on, I had my notes up. October 4th. Hang on just a sec. I had my notes up. There they are. Okay. So October 4th at Sunnycrest Elementary. This is basically the same type of thing we did last year. This year we're going to have Robo Magellan, Build Challenges 1 and 2, Mini Sumo, and Line Following. So this was all just decided last night, literally. So it could change, but go ahead and start planning for it. And we'll post updates as we go. I think that's all I got.
okay.
Oh, you're mute.
All right. Yeah, we're doing a little bit of maneuvering here on my end. So, okay. So, all right. Let's see. Any questions for Lloyd regarding Robothon? Okay. There's some of the resource pages that we have on the SRS website. There's I believe, let's see, I think it's called resources up at the top there, and then you drop into that, and there's lists of local maker spaces, and then also just general robotics related or maybe loosely connected resources. So feel free to visit those and look, see if there's anything interesting for you there. Let's see, have there been anything that's happened recently? Anybody has participated in or watched or anything wants to share about? Oh, let me turn this back. Okay. Let's see. All right, and I'm gonna. Let's see. I see. Oh, yeah, Jason.
Yeah. Hey, how's it going?
Good.
Thanks for the invite here. Excited.
Yeah. Yeah. You. Let's see. Okay. No. Your colleague there who reached out to you.
Yeah.
Danielle. Yes.
Yeah. No. I'm curious. How long have you been doing this?
This the SRS actually started in 1982.
Okay.
So and it began as people just getting together in person in Seattle. Met up in various places around Seattle. We were meeting in person up until COVID hit, and then we went. We had a little bit of a hiatus while we figured out how to get converted over to Zoom. Got that going back in 2021, I think. And so we've been doing these Zoom meetings ever since. And so now we're a little bit more spread out. We have people from different parts of the country now that join up for these meetings. So it used to be just people in Seattle. Now it's kind of people from everywhere. And then we get presenters from all over the country as well, or even all over the world. We've had presenters from Japan, Italy, Greece, Europe, Western Europe, all over the United States. Which has been really cool because it's really broadened our base of folks that we can bring in. So it's actually been quite cool.
Yeah. And, just to your question about recent events, a couple of months ago I was one of the judges at I don't know if you're familiar with the Mate Robotics competition. It's a underwater robotics competition.
Right. Yes.
And
yes.
it was pretty amazing to see the stuff these kids were doing. I mean,
so are you? So that was that over on Bainbridge Island?
No, it was down in Federal Way.
Federal Way. Okay.
Yeah.
Okay. Is that probably at the Aquatic Center, right?
Yeah, at the Aquatic Centers. That was it was the Northwest local, regional competition.
Yeah. Okay.
Yeah.
Yeah, that's we had somebody from the Bainbridge Island, the school over in the Bainbridge Island there that came in person and brought some of those robots for us to see, that was pretty cool. And lots of PVC and silicon sealant and other things that it takes to build stuff that runs underwater. I mean, it's a challenge to build a robot, but build a robot that can actually function underwater for a decent length of time.
And then one that the little leak, you can ruin a lot of equipment fast.
Yeah, but see, the good thing is though, when it comes to arcing and sparking, if you get a fire, it usually goes out pretty quick.
And so actually, you mentioned the Robothon. I'm just curious. I'm not familiar with that.
Lloyd, why don't you jump in and give a brief overview?
Yeah. So, oops, am I on? Yep. So Robothon, it's varied over the years. What we used to do is go down to the Seattle Center and take over what's called the Armory, which is kind of the food court area.
Mm-hmm.
And we'd have multiple contests and demo tables and war. And war is Western Allied Robotics with the combat robots. But since COVID, we kind of stopped doing that. And what we do now is we host two smaller events during the year. One is at the First Wa Field House in Kent. And basically we're doing generally the same contest, just in a smaller venue. And it's a lot easier for us, and it's a lot simpler to, run and so forth. So we'll get together at the field house. We just did this in May, I think.
May
was our last one. And we get together and we run a pop can challenge is kind of the big event. Mini sumo we tend to do all the time. Line following. Then we've got we did line maze this year. And we did Build Challenge 1, which is basically just a robot navigating a 15-foot or 15-foot square, I remember right. And then the other one we do is the one coming up in October. That's our outdoor event. So we do one indoor, one outdoor. So for the outdoor event, we just go down to one of the local schools here in Federal Way. And we run Robo Magellan and Mini Sumo line maze, line following this year. Build Challenge 1 and 2, and
see,
I'm missing one.
So Mini Sumo?
Mini Sumo. Yeah, I'm not missing one. Line following. We're going to do line following this year. That's the one I'm missing.
Yeah.
So,
who are the contestants? I mean, the participants usually. Where do they?
Whoever wants to. Yeah. So those kind of vary. Most, Donna and traditionally Bob and Chaz and John Jennings. Those are kind of they kind of participate or tend to every year. And then we'll get one or two others that kind of pop in.
The contests are open to anybody that wants to build a robot and compete. There's no
that's great.
Yeah. This year we had like 3 high school students pop in and do the line following. That was pretty awesome.
Mm-hmm.
Yeah.
So it's not a lot of restrictions. It's not. It's more of just bring something and show it off.
Party.
For the most.
Bring it in party.
Okay.
We also have demo tables at each one. So if you don't want to compete or you have something that's not set up specifically for one event, you can show it off and talk to people. This year at the indoor one, we had Donna did a presentation on a 3-kilogram mini sumo or a 3-kilogram sumo bot. So we'll do that sometimes. Basically, go to the website robothon.org, and that will have all the information on it.
Great. Yeah, I'm looking forward to getting involved.
Yeah, and we're trying to grow that. We kind of, we shrunk a lot during COVID, right? For two reasons. One, it was COVID. And two, we stopped doing things at the Seattle Center. It just became really problematic with all the rest of the logistics and so forth. But we are growing again. I think Donna noted our Fieldhouse event basically doubled from last year to this year. And so we're back into a growth phase and trying to encourage people to build bots.
Mhm.
So come on
The,
down, bring your friends.
About 10 years ago, the 3 kilogram type sumos were quite popular, and some people were building even bigger ones. I think there's actually classes that go even beyond that. But 3 kilograms lets you build very aggressive sumo robots. These things could literally smash each other out of the ring, not just push each other out, and move very, very quickly. And it's it takes the mini sumos are little 500 gram. There's only so much you can cram into 500 grams, but 3 kilograms is 6 times that big. And you can put a lot of power and a lot of aggression into a 3 kilogram machine. And
Yeah.
people were doing just crazy things, even doing magnetic steel ring and magnets to give the robots more traction, more push. And it got crazy. And I think they were even talking about doing them like on the wall, set magnets strong enough that you could actually have the robots hanging on a vertical wall and have them do it.
Ooh.
I mean, it got kind of crazy after a while. But one of the problems you gotta be careful is don't make it too aggressive or too complicated, because then you scare people away. It's like, oh man, I could never build one of those.
Mhm.
So
Yeah.
we want to kind of we want to
Keep it
we're
fun,
trying to,
but challenging.
oh yeah.
And,
So
and,
go
and
ahead.
as the
What's the typical autonomous versus remote control?
Hmm.
I think they're all autonomous right now. Everything we're doing is autonomous.
Right.
We did get into RC, and there was even talk about having an autonomous one versus an RC one, just to see how well that works, because then it's the strategy of your software against the strategy of a human, and how well does that work? And it's anything is possible, and so hey.
And as the person who has to organize the insurance for the event, I will put in the required disclaimer: no flamethrowers and no projectiles.
James has got a question there. Go ahead.
I just wanted to say real quick that the reason why I get out of bed on Saturday mornings once a month and come and hang out with you guys, even though I'm miles away from you, is because every other robotics group is doing RC crap, and you guys are doing autonomous. Like, there's a bias in this group towards actually doing robotics that
So
attracts.
James, that's actually really good to know, because we were talking about doing some RC stuff last night, and maybe we'll just stay away from that.
Yeah, I would say so. The same thing of these Mate Robotics, First Robotics. They really. I'm glad they're getting kids involved in robotics, but they're not taking it to where it needs to be, which is getting something to do work autonomously.
Yeah, I mean, I agree with you, Jason, but just to be completely fair, they do encourage the kids to do autonomous. They get an extra, what it is, like 30 seconds of operation where the robot can run on its own. And they get extra points for doing things in what they call autonomous mode before it switches back to the RC mode or whatever. But
Yeah,
in general, I agree with you. I mean, I think what's happening is, I don't know. There's, I could talk for half an hour on it. I'm not going to, but I'm probably not going to. But the key is that robotics is hard, and the automation part of it is really, really hard. And if that's not like your interest and your focus, then you can get so much more done with an RC setup. And the other thing I want to say just really quick is that it's not that I have anything really against RC. Like, if you guys want to do something that has an RC component to it, or that just like, hey, let's get the platform working to this point with RC, and then we'll go on, with autonomous or something like that, or let's have two divisions or whatever. Fine, that's great. But in this group, there's actually enough brain power and enough like interest in doing the autonomous that it makes it worth hanging out. That's what I'm not trying to say that doing RC is evil or something like that. I'm just saying that doing only RC is evil. That's what I'm saying.
A quick editorial comment on that. As a mentor for one of the first robotics groups, and I had them come earlier this year. They have a season that's only 3 months long in the fall, and trying to get the autonomous stuff to work in that amount of time, given a new crop of kids every fall season, is probably not really feasible. So the RC for the school teams kind of makes a lot of sense.
Yeah.
And I think a lot of the FR, well, I don't know so much about the full First Robotics teams because I don't participate with them. That's ridiculous. But the First Tech Challenge teams, I've mentored a little bit and worked with a little bit, and they build up their teams over several years. So the smart teams will try really hard to get freshmen or younger kids involved, because those kids are then going to pass on the legacy to the next year, right? It's like this. And if there's any positive thing that comes out of First Robotics, it's that. It's thinking beyond yourself and thinking about the investment that you're making in the future generation, as it were, but a future year, not full generation, but a future year. So there's a lot of good in that, and it's a positive thing.
Yeah, that's what really attracted me to this group too, because like if you've watched combat robot competitions, those are there. That's 100% remote control, and that's just what they do. It's very simple, pretty simple, and to build robots in that class, because you got an RC controller, you hook it up through ECSs or ESCs, and you can. It's easy to build the mechanical part of that kind of a robot, but to create something that actually has a strategy built into it. The robot that's actually can figure out how to do stuff. That is hard. I mean, it's the hard. I think it's the hardest part of robotics is the software. And figuring out how to make the robot do interesting things on its own, and that's a huge challenge. And so. Yeah, so the RC thing, it's interesting from a demo, maybe from a basic demo standpoint, but it's like, I hope we don't lean, we shouldn't really lean in that direction. It's maybe that can be kind of a peripheral thing, but I hope the core stays. Let's build robots that are autonomous, that can do things for themselves.
Yeah, and I mean, at least for my company, I hopefully get to do some sharing later, but it's all about trying to solve that. Why is it so hard? And really opening up that capability to more people. It's just, if the word Linux comes up, I mean, you've lost 90% of the, it's, and that's just the beginning of your, the nightmare.
Yeah.
So.
Right. All right. Well, good discussion. Thank you all for jumping in on that. Let's keep moving along here. We haven't even gotten to the part where you guys get to share what you got, but we've already sort of started it though. So just for some links that'll take you to things that are happening around the area here. Robot Events is a website that has stuff happening all over the country, so you can go there and let's see. I am hearing, is that Randy? Yeah. Has stuff happening all over the country, so you can go in there, check on competitions and things. And then the Snowco Makerspace is a cool space that Chaz runs and is involved with up in North Seattle, South Everett, North Seattle, whichever you want to call it. And they do regular meetups up there, doing robot. They do competitions and other things, and so there you can get links to those places on our website, and you can also just Google Snowco Makerspace. That'll get you there. Let's see. James, did you just raise your hand again?
No, I was just applauding Chad's work up there with the Makerspace.
Yes, it's very cool stuff. Yeah, I love the stuff that they're doing. Okay. Well, that even had another thing, past event comment there. I didn't realize I had that on two different slides. Presenters. So I'm always interested in, possible presenters, and just about anything is wide open. Feel free to reach out to people that you encounter, stumble across on the web, maybe meet at a conference, whoever, wherever it might be. I'd love to meet up with them. You're welcome to tell them all about how that works, what a presentation to the SRS kind of looks like, if you can. And you can, pretty much make any sort of arrangement except scheduling. Just have them contact me or pass their information on to me, and then I will reach out to them. We can handle people from most parts of the world. Actually, it's reasonable time zones. Generally, Central to Western Europe is about as far east as we can go with the meeting time at this time of the day. And then when you start to get over to the Eastern Asia, it gets to be middle of the night there. So then we end up having to, if we want to get one of those folks, we have to shift our meeting time to have them come on when it's not the middle of the night. So I haven't found anybody yet that's been too crazy about doing that middle of the night type of stuff. But some of you guys might be. But anyway, so just use send the information to the Seattle Robotics Society at Gmail, and then I'll reach out to them. And Robert Kellogg has been sending me just tons of stuff, and I have I can't even hardly keep up with the pace that he sends me stuff. So I do have lots of stuff, but I'm always open to other new presenters and other presenters. Also, if any of you have something that you would like to share, would love to put you in the spotlight. So reach out to me and let me know if you've got something that you're working on that you would like to share, or something that you have some expertise in or know about. That would be great. We also sometimes will fill in spots with just open discussions. So we've had a lot of different open discussions over the years, and these are just some potential examples. There's gazillion more possibilities. So if you want to just lead a discussion, you don't have to be an expert in the particular topic. Maybe just gather some information, find some YouTube videos, and then we'll just kind of do back and forth around the room, around the web, sharing Q&A. If anybody has answers, or maybe nobody has answers, but they're always fun, and lots of interesting things that we could talk about. So this is currently the lineup. I need to get on this and see if I can book the rest of the year. I got nobody for September right now, so I'm looking for somebody for that spot. And I know Robert, I know you're on the docket somewhere down the road here to do more chat about processing vision data. And so I don't know if you've got any feel for when you might be able to slot you in.
No, not right now. We've had some medical issues around here, so the last couple of months have been absolutely crazy.
Okay. Well, let me know, because I know there's people want to hear from you. So you're more than welcome, and whenever you think you can do it, let me know.
Yeah, I'm trying to put together something, but it's going to take a little while given the current situation. So.
Okay.
Yeah, and Stephen, I'll reach out to you and try to get something scheduled too, to do some training on how to install our software and start automating your AI. I mean your robots.
Okay, that'd be cool. Yeah. So, well, as you can see, September and November or December, those are open slots right now. So if any of those feel like they would work for you, let me know. Okay, so this is let's see, this is the last information slide here. Just some kind of general stuff. Of course, the Zoom link is the same every month, so you can go to the front page to get to that. I will post the recording. It'll be up on YouTube fairly quickly. I just have to upload it, and then when I create the meeting post, I'll pull all of the information, the chat window, the AI summary, meeting slides, if there are any, and put that all together into a post on the SRS website, and you'll be able to kind of pull it all together. Merch store, yeah, okay. So I think I've kind of covered that. Okay, so in a little while, I'm going to have Jon Davis. He's going to good friend of mine here, and we're gonna talk AI. So this is going to be a Q&A. We had sort of originally hoped for doing some kind of a portable AI on a portable platform. That may come down the road. At this point, he's not really ready to do something on that. So this is going to be a kind of a general open, just open discussion about AI. And so if you've got ideas and questions and other things that come to mind, make note of that. And when I bring him up here, you can go ahead and ask your questions, and we'll just kind of toss things around.
Clarification. So I'll still talk about the portable platform discussion, but I won't be able to demo like I'd hoped. I mean, as on one of these, on a device like proper, I will be able to demo on my laptop. So.
Okay, so there you go. I stand corrected.
A bit, a little bit,
just
a little bit.
Okay, so okay. Let's see, it's 11:30. Okay, so we got potentially some. All right, so we've already had a little bit of kind of round the web sharing here, but this is kind of open now. If anybody has got any demos or anything in particular that they would like to share, something they want to show.
Yeah, I'd love to just show a couple slides and prime up what I'm working on. And
all right, let me go ahead and stop sharing, and you can. Okay, there we go. So go ahead and put your slide up there.
All right,
Jason.
let's see if this works. Share. So it really actually quite a good segue, being that. Let me see. How do I turn that off? Okay. Oops. Yeah. So our company, kind of to that point about how hard it is to actually take all these technologies, AI, automation, and talking to robots, talking to sensors, individually, they're all doable. There's lots of open source pieces and stuff out there, but each one of them takes quite a bit of work, and started the company to really look at how do you make that easier? Why is it so hard? And so our focus is really on this idea of plug and play. And so just to kind of put it in perspective, when I did my thesis, it was on AI and fuzzy logic. And this is back in '96. This is the robot I made for, to show off the control system. And I really had fun building it. But after I graduated, I realized, well, I spent 80% of my time just trying to talk to these sensors and get the processor up and running in a way to actually communicate. And only 20% of my time actually on the research that was the valuable part. And then I went off, worked at a few different Navy labs, worked on robots. I worked in the Marine, oil and gas, defense. And these are just some of the robot projects that I've worked on. And again, every time it was the same thing. And it was quite a team of software people to actually make these very expensive robots do some very simple things. And it never got easier. And so started the company to really focus on that. And started with actually making some trying to make some smart sensors that actually, could provide the information of the robot it needed, like the location of an object, for grabbing and manipulating. And I thought, well, how hard could that be? So you get an AI model. There's lots of actually training an AI model is not very difficult. There's lots of tools and stuff out there, but you end up with a file, and then with that file, you want to do something. And one of them is connecting up your sensors, whether they're sonars, lasers, cameras. Uh, each one of those, is again a project. Talking to them, you've got to manage the data, move that data around, save that data. You've got to talk to control systems, whether they're pan and tilts or robotic systems. Then ultimately, you need applications that do something with that AI detection. It's great, what good is an AI running if it's not actually there's no action involved? And then you need a user interface, right? And so this is, those components around there are the same in almost every project. I mean, the cameras might vary, the control, the control system might vary, but up to the actual what do you want to do, it's almost every project is 90% the same. And so that, that's what we're trying to solve So what we did is created we've been working for 5 years on this, probably $4 million into it, but it's a full-featured low-code software platform. Most of it's open source. We have some applications that we license, but it try to kind of take the approach of, I remember when I got my first PC, it had DOS on it, and it was great. I was an engineer, but to the rest of the world, that was, not a very useful tool. And then Windows came along, and as much as people hate Windows, it did really take that technology and bring it to a much larger group of people. And so one of the things we focus on is this plug and play hardware. So we're not plugging keyboards and displays in and printers. We're plugging in, again, sensors, GPS, INS systems, control systems, and being able to just plug that in and have it auto detect. Again, taking that AI model and actually connecting it up to your system and your devices, taking the output, having applications and scripting system that takes the output of that AI model and quickly, take actions, and then a user interface. And so, again, one of the challenges on these systems is why a lot of them you can hook up a display and a keyboard. When it's in a robot, you need to be able to actually communicate usefully with it and intuitively. And so we actually run on our software on the device a web server that provides a user interface. And for you guys, everything at the very bottom, we're built on ROS and ROS 2. And then we have different API and SDK layers above that that continue to abstract and reduce the amount of code to the point where um, you can almost create something with no code. And so this is just a quick demo. So like I said, our software is the big component. Uh, Almost always it's deployed on one of these NVIDIA Jetson, embedded GPUs. And right now, we're about to release it as a container, which would make, the deployment a lot easier with all the prerequisites, all the requirements, Python and components and stuff, all pre-built. Uh, but again, someone could go and get the software and build that up from scratch. But for right now, a lot of times we just sell, boxes with our stuff on it. So there's a quick highlight video of those different components. And so one of them, again, plug in your sensors, your devices, and it automatically detects it and provides these, web-based user interfaces for setting up the system. Then connecting that data to whether it's AI models or different types of analytics. And then ultimately, application. So either creating a quick application that, takes action, or we have this scripting system where you can write a short Python script against our API and it, and take actions. And then, like I said, we sell different hardware, but it's really the goal is to make that easy. And I'll just show a couple example projects. Oh, so this is a company called Ocean Arrow. They make this surface vehicle. It's got 4 cameras, that provide a 360-degree awareness, and then it has a pan and tilt with a high-res floor camera on it. And so they're really, the robot's amazing, but their specialty is getting it to go out, run a track, and then come home. And so their customer ultimately wants it to do something while it's out there. And so they embed our software in one of those NVIDIA Jetsons. Then, per project, they can just drag and drop their different AI models into the library, and they're available for, switching real time as the mission changes. And then again, creating these mission scripts that can be started and stopped as the mission continues. And so for this one project, it was, again, looking at those 4 cameras, looking for particular targets, detecting them, telling the vehicle to stop, hold station, and then turning the pan and tilt, the high-res pan and tilt, getting a picture of that, and then ultimately for this, it was saving that data and sending that and getting it to their customer as fast as possible, the data. With that said, though, really what gets me excited is help it, like making this so easy that these students we're working with Lane Community College, uh, they have a drone program, and these are students that most of them have never programmed before. And so with our system, they're able to, add that NVIDIA processor onto their drone, hook up the camera, hook up their, in this case, it's a Pixhawk running RGPilot, and really quickly create these scripts that, in this case, it was a search and rescue project where you could choose the colors of, like the people that you were, of the clothes on the people you're searching for. As the drone, was flying around on its predetermined mission, the camera feed was, running into our system. It was running that AI, and then if it detected something, again, it would tell the vehicle or the drone stop. It would get a high res picture, grab the GPS information, and then send that, to a remote operations rescue. Um, and again, they're very similar. Again, detecting, hooking up the hardware, detecting something, and taking some action. In theory, very simple, but as anybody knows that's worked on any of these systems, uh, it's amazingly hard. And so I'll just leave it at that. But I'm really excited to actually, like I said, I brought up the first robotics and stuff is helping to break that barrier between uh, just RC and autonomy by making it much easier than it is today. So, any questions?
Isn't
You got one?
aren't you doing the presentation today, Jason, or did I misunderstand that?
Nope. Believe it or not, no. But we will get Jason here.
No, no. I'd like to give a presentation on, actually, I can go in more detail about the, the architecture and how to install it and things like that, and show some more demos. But yeah, I just wanted to kind of prime up
Yeah.
what we're doing, and I thought it was a good fit for where the discussion was going.
Yeah. So this sounds like something that would be great for a presentation. I'd like to hear like a lot more about it.
Yeah, and we will definitely get him back for that. Yeah. So it's actually a different fellow here, John, who's sitting next to me here. You see him in my camera view. He's actually going to talk about AI today as well. So
I'm just horrible with names. So somehow or other, John became Jason. I apologize.
Well,
yeah. Thank you, Jason. That wow. One of the things that the question that popped into my mind, that one where the drone is flying around looking for the particular color of target, when it sends the GPS coordinates, is it able to estimate the GPS coordinates of the thing that it's looking at?
well, it has a heading, and then you can add some analytics that say, okay, I know how big roughly a person is, right? And I know my camera field of view, right?
Yep. And it
Because
basically geometry and figure out.
we support like
Okay.
Z cameras where we actually, if you have a Z camera and you've got the depth map data, the depth data coming in, we'll grab
Yep.
that and get a much better estimate. But
Yeah.
the range on those cameras is so short that for a drone, it's not very valuable. But most of our
Okay.
customers will just say, okay, I roughly know how big my target is, and so I can estimate the range.
Okay. Yeah. Cool. Well, that sounds like an amazing products that you guys have developed there. So I'm excited to hear more about them. Okay, so let's see here. So does anybody else got something that they would like to share on?
Is anybody a huge fan of Shaky the robot and interested in classical AI? There's a thing called strips. I don't want to push it because I think maybe I'm the only person that's really crazy about that stuff. I don't know. It's just to be clear, my take on it is that the new AI stuff that everybody's doing is absolutely fantastic. I love it. I work with it all the time, and I think it's wonderful. I think that like kind of stuff that Jason's doing is great. But I also feel like old stuff works, new stuff works better in combination with old stuff. And I can't remember if I've shared this or not, but this is the DDE robot simulation environment. And this code right here is strips from the Shaky Robot project, and this is starting to be used more and more in combination. So people use this classical AI like strips to do stuff for providing training data for the newer AI, or because the newer AIs, although they're fantastic at finding a solution, they also will hallucinate a solution. In other words, they'll come up with a solution that sounds really good but is complete BS, right? And so what you can do is you can use a classical AI to then hold the new AI's feet to the fire, and come up with a tested solution, or at least provide a way of testing the solution at a higher semantic level. So this is a little script that was written to actually implement a version of strips, and it's a fair amount of code, but it runs right here in the browser, so it's great for students and educators and all that kind of stuff. Yeah. So Terry, this is exactly what it is, that you can use the classical AI as the pharma to treat the hallucinations of the new AI. So just to show you the key here, people are going to think that this is a Tower of Hanoi problem, and it's the Tower of Hanoi problem, but it's being solved by an AI. So it doesn't have to be just one Tower of Hanoi problem. It's you specify what you want the goal state to be, and in this case, I've set it up to be 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. And then what happens is, in the instant that I hit eval, boom, right there, that job showed up with it finding the solution, which is amazingly fast. And then what it's going to do is it's going to go through and simulate picking up the boxes and stacking them in the correct location. And yes, I know it's stabbing the boxes. That's the way our sim works. I didn't say it was accurate. It just said it's, and this is one of the things that we're trying to do, is we're not trying to be perfect. We're trying to be good enough to get the idea across. And I just finished teaching a summer camp for UCSD Extension with a bunch of high school kids, which use this simulator, and not necessarily this particular script because it's really complicated, but simpler ones. So the point here is that it finds the solution, carries out the instructions. And so it's able to take that high semantic level information about like what order the boxes are in. And then you'll see now that it's like, from white to black across, right? Like lightest, lighter, less light, darker, 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 dark, right? Starting off with like a random stack. And so you can start with the starting stack. I don't know where the line is. The line is in here somewhere, where you start with the actual starting stack. Can be anything. So there you go, right? So let's, like, for example, at the start of this, it was like this, and I can change it to, I don't know, maybe that one is 2 and this one is 9, right? And when I hit eval, you'll see that it'll change the stack down here. And I can set whatever goal state I want, right? Like I can set, this other goal state down here. Or I can, change it to put all of them in order in the center state, right? So there's all these different things, and it'll just find the solution. Now, it takes longer than it should to find the solution. An LLM would do a better job of finding a solution. What this does that's fantastic is it evaluates the solution that was found to see whether or not it'll actually work or not, right? And it doesn't have to be applied to, ordered stacks. It can be applied to anything. So some of the experimentation that we're doing is things like explaining to, ChatGPT or Gemini or whatever, that you have a robot that can only do certain commands, and then asking it to come up with a solution that takes the current world state and changes it into a new goal world state, and then using this LLM to test that solution to see whether or not it actually accomplishes the job. And then if it does, actually try it in the simulator and see if it accomplishes the job. And if it doesn't, then go back to the LLM. And this is the tricky part. Taking what went wrong and describing it in English language so that the LLM can then come up with something that's a better solution. And the reason why that's interesting is because I think there are potentially a lot of things in the real world where somebody has written about it somewhere. Like the way that you glue a strake and get it to slide into a hole is that you wobble it around a little bit before it slides into the hole, right? Or the way that you could do this is, here's a way to get this to work correctly when you're trying to do that. Somebody's written about that, and then the LLM may know about that, and then that may come out in the instructions that it finds for you, which then make it potentially more robust. All right, that was enough from me.
Okay.
Just just to
oh,
comment on all of this, we talk about AI and classic AI versus the neural networks and things like that. If you really look at it and decompose things, neural networks are pattern recognition algorithms, period. That's what they do. You need something else on top of it to actually get anything accomplished.
mm,
And that's the classic AI.
mm. Hmm. I was going to comment, Jason, there was a question from Terry James there. It's about the FLIR. He says, was the customer using that underwater or above the surface?
Well, that particular vehicle, it can dive for short periods of time, but it's the camera was in a waterproof housing. But in general, it's used on above the surface.
Above the surface. Does FLIR even work underwater?
Right.
Yeah,
That
well,
was
there's
why I raised
companies.
the question.
There's companies actually work with a company called Deep Sea Power and Light, and they make I forgot the model number, but we just finished integrating that. They make a FLIR, what is it? A black fly, I think. Anyways, they in a watertight housing. Actually, I got it, and I'll show it to you in a second.
Okay.
Yeah.
All right. Well, we are close enough to the top of the hour here, I think, to go ahead and take a break, and then John will I'll get John going. We're gonna probably grab a cup of coffee and all that kind of stuff here. So I will let you guys. You can go ahead and continue chatting if you want here, but I might have to cut you off if you get don't try not to get anything too deep. Okay. So let me see here. You should be able to. Can you? Oops. Let's see here. Okay. All right. Can you? Oh, I got to guess. I got to reshare now. You got something to show there?
Yeah, I'll show you. This is the FLIR black fly camera, really high resolution, gigi. This is the the watertight version of it, right?
Oh, nice.
Yeah. So I think $300 and $3,000, but these connectors, the connectors themselves cost about $400.
Okay. Yeah. Yeah.
Isn't it amazing how much technology has dropped in price, or like to get like not necessarily a perfect version of something, but like a useful version of something. LiDAR is another example. It just dropped through the floor on the price. Time of flight sensors, all that kind of stuff. Really amazing.
Yeah. All right. So I'm just gonna leave this. You guys can see. Assume you guys can see my slide there of for John. I'm gonna just leave that up, and you see that there's a clock at the top. So somewhere around noonish, according to my time, Mountain Time. So we got about 5 minutes or so. So with that, I'm gonna go and take a break here. So
I can't hear anybody.
It's because nobody's yakking. For once, I'm keeping my mouth shut. I'm waiting on Terry to finish his thought about the cost of LiDAR dropping. Or was that, oh, you were saying hooray on the cost of LiDAR drop. Oh, okay, there we go. I got it now. Sorry. Sometimes it takes me a minute.
Steve, looks like you're talking, but you're muted.
No, we're here. We were just he was just
Yeah, we're just kind of figuring some logistics out here. So yeah, John had a rough evening last night, so he's a little worn down. So if you guys want to carry the ball, we're perfectly fine with that. But and I'm just to be honest, he's feeling a little intimidated by some of you guys. So be easy, go easy on him, okay?
Hey, we don't bite much, and when we do bite, most of us have had our shots, so the chance of infection is low.
Okay, I just walked into this conversation. It sounds really weird. What did I miss?
So anyway, okay, I'm gonna let's see, I gotta stop sharing my screen and let John share his. So this is my good friend Jon Davis. I would and he's being very gracious in doing this for me. So I would appreciate you guys all just make this a good experience for him. I would love to have him come and talk some more, but if he gets too intimidated by you guys, he might not want to come back. So he's gonna I'm gonna let him take over, and it's gonna be kind of a AI Q&A and a few other little things. So John, go ahead and tell us a little about yourself, and then take it away.
Sure. Okay. I'm gonna share my screen here. So my background is first of all, I am not I don't do what you guys do. I'm not in robotics, so but I am in software. I've been doing software development for 27 years now. So primarily Microsoft stack, moving now lately more into Python, but up to this point, up to this year, it was primarily, it was initially like front end, then became full stack, with SQL Server and all that stuff, and then moved less on the front end to the back end, and now I'm kind of with the recent innovations with things like Cursor and Windsurf and all that stuff. I'm back to full stack again. Anyway, so yeah, but my day job is all business applications, but lately it's been specifically AI applied to business, right? So the company I've been working with for the last 5 years was called LeeSock, and they're in a just this background information. This isn't very interesting, perhaps, but just so you know, it's multifamily sales channel support, but with automations, and so I had built basically a chatbot. If you go like to apartments.com for, looking for an apartment, chances are likely you might see a little chatbot experience on the bottom right. And there's quite a few sites that have this with our engine. I basically was one of the main developers for that little chatbot experience, and that was kind of early AI. We leveraged a product called Dialogflow. So that was back then. That was before LLMs really took off. We augmented that LLM. We augmented that chatbot with LLM so that responses could be a little bit more human understandable, human readable, and less predictable. So back then, yeah, it was basically the way it worked was, basic machine learning with a series of training phrases. You would input your by the way, Steve, just so you know, all the clunks you make is overheard, I'm sure. So Steve's back there making coffee off the floor. Oh, we got visitors at the door. Sorry. Yeah, anyway, so training phrases for utterances to map to intent detection. So with intent detection, then you would have predefined behavior for what to do with that intent. And so you could do that with a few hundred of known intents. You could drive a conversation that way. And that was the early days. Now with LLMs, you can still use intent detection, but it's more to steer the conversation rather than force the conversation. So that was the original thing. Now, what we more recently built was this thing called Conversation Insights, where if you have a phone call with an actual human being, we would review the phone call and kind of analyze what happened. Here's an example. You guys should be able to see my screen. someone interacted. You could listen to the call, review the transcript, and then this leveraging a transcript, you could review the context of what happened, and if any information is gatherable, then you could get analytics on that. And then we have another product that kind of augments this, and I'm not going to show it here, but it's basically reviews the agent on how well they handled the conversation. So you'd have a series of scorecard questions, and as basically the question would be like, were they polite? Did they answer the call with identifying the apartment complex? Did they manage to get a tour scheduled, and all that stuff? So if you get like a really good score on that, then the idea is you get bonus incentives for that agent, so that becomes really tangible value for business, for the rental office, and for every single agent. So every single agent and then is able to leverage. You're leveraging AI to figure out how to get your people paid paying the best people for what they do with their sales. So this is just an application of AI. You see on the top left there, it says Phoenix. So LeaseHawk got bought out by a company called Funnel Leasing, and they renamed LeaseHawk to Phoenix, and then Phoenix now becomes the brand name for all the products that LeaseHawk had built. So now I work for Funnel Leasing, and I am in the process of unlearning everything that I built and diving into a whole new set of challenges. And it's basically a CRM that they've got with some of their own AI tech. So I'm going to be delivering on stuff there. Yeah, so that's my background. This is prior to LeaseHawk. I was not working with AI, and but I have very limited experience with actually working with like robotic hardware. I did have I bought it, like I had an Arduino and a Raspberry Pi, and I'd like to dig that stuff out again or get a refresh, a more up-to-date one. This particular machine that I'm talking to you guys with is a company issued. By the way, I think never mind. I was wondering if you were sharing your screen, but you're not.
Oh.
We have a third monitor here that we were using to see what's being shared, but I know that's I'm sharing my screen, right? You're not sharing yours.
No, you're it's your screen.
It does see shared there, so I don't know if both of us are sharing.
You are viewing Jon Davis's screen right here. So
Good.
Yeah.
Sorry.
No,
Sorry, guys. What was I saying?
Third.
We're seeing your screen, John, if that helps at all.
Yeah.
Yeah.
I'm trying to figure out, continuing where I was getting at.
You haven't worked with robotic hardware.
So I'm currently running on a MacBook Pro, the latest refresh, and that is relevant to today's conversation. So I wanted to talk about applying LLM on the edge, and again, I wish I had an opportunity to do this. It's not hard to do this. You guys should be able to do this. It's really going to be it's going to be high level because I don't have I didn't have a chance to or take the chance to actually propagate this to an actual Raspberry Pi and see it, do this. But but things have changed since a year ago. Like when I did present a year ago, and I talked generally, maybe it was a year and a half ago.
Yeah.
How long ago was it? We talking about basically like exploring ChatGPT and LLMs in general, and just enjoying everything that all the major changes that are happening in this space. Was it 2 years ago?
No, I think it was actually last summer.
Okay.
Last summer.
It just seems like forever ago because in this space, so much changes so fast. But when I presented before, generally you're kind of limited to network-based interaction with an LLM. So you kind of had to connect to OpenAI or Anthropic or somebody, and there was local hostable LLM support with Olama and all these other. There's a what's it called, CLUM or something like that. Anyway, so yeah, so there was support, but the hardware wasn't there. It was available, but it was just not easily accessible. So you'd probably need like a pretty hefty machine in order to get it to happen. But these days, just because of the demand, it's really shifted a lot. So as an example, so I'm gonna pull up. I was showing Olama before. You guys can see my screen, right, with this little command console.
Yes.
So if I type Olama here, and again, half you guys are probably normally like doing this already, but even so, I'm gonna just go down this path. So if I do Olama list, I can see what I've installed. So this is going to be an older model with a Llama 3. If I do Olama run Olama 3 1.8b, it's just like 4.9 gigabytes, and what the way that this is going to work is it wants to work off video RAM, and so you can use your GPU readily. And on Mac hardware with the M chips, what's really nice about that that platform is your RAM is shared with the VRAM. And so if you get a system with a lot of RAM, that all the RAM is also available as VRAM, which is readily accessible to your GPU, which is readily accessible to your LLM execution. So if I come in here with Olama and I say, hello, you can see how fast it's going to spit out, how fast that went. You almost didn't have to see anything happen there. It just, a year ago, it would be about 1 word a second on the machine that I was using last time. And it took, I don't know, 2 minutes to load up the model as well. Can you tell me a long story? And you can see it writing a story out with pretty decent detail. So that's exciting because now you have new opportunity to get off the internet and host the stuff locally, and which opens up new opportunities to let's say you're working with a robot. Like now I'll get into some use cases to where this is actually useful beyond just running off solar power, to use a interactive love chat to your love bot or something with a keyboard. There's more use cases than that. Yeah, so that was actually Olama is a handle because it actually hosts an HTTP server. You can connect software against that HTTP server. Here in this case, it was hosted in a console, and so by default there's no like UI other than a console app.
James has got a question.
Yeah, James.
Yeah, sorry. There seems to be a wide range of prices for things that all have the name MacBook Pro. I was just wondering if you could share a little bit more detail about the exact specifications of the machine that's running this fast, or if you don't mind sharing, like how much did you pay for this beast?
So this one was issued to me by my employer, but I did look it up. So what you guys might be interested in, I'll talk about this, is the Mac Mini. But if you look at the MacBook, let's see here, sorry, MacBook Pro. I'll track down the spec, the one that matches the spec that I'm using right now. Click on buy.
Yeah, the Mini's back to very affordable prices again, as opposed to a few years ago when they were obscenely expensive. So I was shocked to see how low cost the M4 Mini is.
Yeah. So for less than 10 grand, you can, and maybe even half that, sorry, less than $1,000, maybe half that, you should be able to get started without a problem. I think this is the one I'm currently using. I'm not sure if it's, I don't think it's Max. I think I'm using M4 Pro. And that's the M4 is the current CPU. And I have 48 gigs of RAM right now on this machine. And that is not upgradable with the Apple. That's downside with these guys. So make the initial heavy, massive, ridiculous investment with Apple, and then you're going to be good to go because you're going to be stuck with it. Um, times have changed. Yeah.
So roughly $3,000 or less is what you're saying.
Yeah, I think this one was probably this guy right here, the 2500. Yeah, the one I'm currently using.
That's the machine he's currently using, but the Mini just came out with an M4 model that was under, I think, $700. That is that using the M4 is a very beefy chip in the first place, but the memory complement on that is probably low end though, and you'd want to push it up.
That's right. Yeah. Yep. And the chipset does matter. I don't know how much the CPU is involved with the LLM processing, but the GPU, I don't know how much the M4 Pro versus just the regular M4 will affect the GPU, or if the M4 is actually doing some GPU work. But I believe my current machine that I'm using is the M4 Pro, not as opposed to the M4 Max. Yeah, I believe I'm using the M4 Pro. So, just for comparison's sake. Anyway, what I was getting at on here was Olama, HTTP server, no UI except console. However, there's other options. And being on a Mac, but you can also do this on Windows, is LM Studio, as well as something called MSTY, Misty. So if I bring up LM Studio, I get this interface where it's basically a full-blown GUI, which is kind of nice. And from here, I can go and find some models to download from a GUI and download them and play with them. And by the way, and I'll get into this shortly, this liquid model, which is really, really interesting, LFM2. It's not an LLM. They've got their own approach to building this model. It's like an LLM, but it's usable like an LLM, and it runs on the LLM runtime. But I mean, like LM Studio, but an Olama, but it's technically a different training approach. And I don't really have a lot of information about that. I'm going to share a link about that though. Where is that? Sorry, this thing is hiding my view. This particular version, LFM2, came out just like a week ago, and it's pretty neat. Oops, I got my screen mixed up. Let's find the Zoom, share that link. How do we get there? Chat. There you guys go.
Okay.
All right. I'm going to show that one off actually. So let's I wanted to write a little story. So I think I have that one loaded. No, I've got Gemma 3 loaded. LFM2. So you can see this little progress bar. Okay, it's done loading. So if I run that, this is like Grok seed, GROQ, Grok. So that's a tangent, but you can see how fast that went. And it went actually 124 or 127.24 tokens per second. I was getting like 1 token a second a year ago, which like a token is like roughly a word. So like it's night and day. Now, when I was talking about a year ago, that was without being able to load it up into a proper GPU. It was better than that for any decent machine that had a GPU on it. But like nothing compared to this. So 127 tokens per second, you can see how fast that went. If I did something like this, I've got
so let me just read this prompt that I had I've run this earlier. You're executing locally on a MacBook Pro with an M4 Apple Silicon chip with about 48 total shared RAM. What are some cool ways a Robotics Society member would leverage LMs and other AI on such hardware, where the goal is to keep it local? Limit to ways that can be prototyped on such a machine, but deployed on something like a Raspberry Pi, where there is some limited GPU, but still some acceleration available. Now, by the way, I didn't mention this. This model that I've been demoing, 1.2 1.2 billion token training. So the whole thing loads in at less than 2 gigs of RAM, of video RAM. It's tiny, 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 tiny. Very, very feasible. And you can see it outputting this. It's not just fast, but it's actually remarkably knowledgeable. If I look up here, it talks about on-device data pre-processing and feature extraction, real-time decision-making with local LLMs, local model training and fine-tuning. I mean, it knows things about TensorFlow and PyTorch and all that stuff that you can play around with in Python, and so on and so forth. So I would think that compared to like maybe a year and a half ago, the best models would probably be something like ChatGPT 3.5. And I would imagine like the information on here is probably a little bit better than it was back then, even on the higher end models a year ago. So it's not that we've arrived. It's more that if you're not building for this for tomorrow's model, building on this for tomorrow's model, you're way behind. And I'm saying that like from a perspective of business, like expect that whatever you're going to build, if it just comes shy of good enough today, then you're all set for tomorrow. It's just a no-brainer. And this is actually something I'm kind of frustrated with my shame on me for even saying it, with my employer, because they're still hand coding what should be all AI driven. I'm like, guys, these models are getting so dang good at, with such small packaging and such ridiculous performance that even if it's not going to work today, it's going to work tomorrow. As long as, you keep hand holding it and, you keep working with it and keep downloading the latest model. It really is a waiting game as opposed to your own brilliant, sophisticated code doing all the things. And it's dummied down a lot of the human side of things, like your young geniuses are becoming less valuable. Where, those of us who've been writing code for a while as well, like our own personal value to the industry is waning, because people can just load up these LLMs and they know what, like, these LLMs are able to write code better than me now. And that's true as of maybe half a year ago. I no longer write code with like my own code anymore. I mean, it's more, I fire up Cursor and Windsurf, and I'm kind of switching gears talking about this, but I fire up Windsurf or Cursor and I do command and control now. I don't like, and so I study the code that it outputs. I catch it doing things that tick me off and come back and yell at it. How dare you change this thing I told you not to touch or whatever. But it's really like looking over the shoulder of a junior programmer who's stupid, genius, smart. And there's no repercussions for it to do its own thing other than to stop using that model and try a different model. And so these models compete with each other. So it's like I say, it's a waiting game on the models. So yeah, so this is a cool model. Speaking of models, This one is a really interesting model, this liquid LFM2. It's not a normal LLM. It's an LFM, whatever that means. I encourage you guys to read this thing because it's just a different approach. Their whole neural network approach, whatever it is, how they did the computing science on that is just, it's like 5 levels beyond my IQ. I don't know how to read anymore. I just don't. So, but some of you guys, no problem. So anyway, I thought it was a curiosity. That said, so looking at Qwen 3, I wanted to pull that one up. That one's more common model. This is a Google. So, sorry, that was Gemma. Gemma's Google. Qwen 3 is China. DeepSeek is built on Qwen 3, as far as I know. With Gemma, look at the performance on that guy. I write me a story about a dog named Spot. Just the performance real quick. And it's gonna have to load it for, okay, it's already loaded. So it's pretty decent performance. You can see how fast it kind of outputs. It's the same. It's a little bit slower than that last LFM thing we saw, but it's very, very usable for, I mean, it's outputting faster than I can read it.
Yeah.
And that's it. If you're actually trying to use an LLM, this is a 12B, so it's going to be about what 16 gigs of RAM, something like that. A video RAM needed for this particular model, something like that. It's something roughly 1.5 to 2 gigs bigger than whatever the B is. So it's 12B would be like roughly 16 to 20-ish gigs of VRAM. It's my experience. Now, here's an interesting thing about the model. You see this little icon here, this little, it looks like an eye on it. And it says this model can process image inputs. This is a multimodal. So what's interesting is I can go in here. Again, this is all happening just on my local machine. It's not happening on the internet. So you can see I've got this picture of this dog kind of biting at this sandwich, right? Can you describe this image? And it's looking at the image locally on the machine. Like this is totally different from your classic AI. You're not using your classic machine learning. It's leveraging the multimodal LLM to do this locally. Again, this is year and a half old tech that you guys have seen this before with the release of GPT 4.0 and Google Gemini 2.0, I think it was. But what's fascinating is this is on the local machine. You can see how fast it did that. It was able to fully analyze that image, fully understand not just dog sandwich, which is your classic AI is going to be able to do like, okay, this is a dog. Okay, this is a sandwich. It's in this box, right? No, it actually it can pick up nuances of what okay, what interesting artistic elements or even emotional elements are being portrayed in this image, right? It's playful, slightly humorous photograph. I mean, it understands, because it's been trained, like it understands context about from similar images. That's the way that it trains it on. Context that can then translate in readable text about that and can make sense about it. So yeah, somebody had a question?
Yeah, this is Jay.
Jason.
Yeah, so I'm quite fascinated. And so this is not, you're not connected to the internet at all. This is all just running locally.
Yes.
And
I am on the internet, but it's this model.
right. It's not leveraging any connection. And so as far as to actually deploy something for a particular application, are you doing some kind of training in the cloud to get, to really, tune it into that what you're trying to do and then download it? How does that work?
Well, Google did this. So Google trained this particular model, this Gemma 3, and it's a multimodal LLM model.
Okay.
So they trained it on text, they trained it on images, they probably trained it on speech. And so in theory, I could also, depending on the, the host, I might be able to have a live conversation with it as well without doing text to speech, speech to text
Okay.
translation.
So actually, let me just take that to where my question. One of the things that we want to do is we've done a lot of work on creating these APIs, documentation, lots of example code of how we want the repetitive ways of creating an application, turning an AI, creating a user interface. The next step, a lot of that work was to make it so we could train one of these AIs to actually look at it, and then you can just say, "Hey, I create an application that does pan and tilt tracking, on an object." What would be the process to actually train an AI like this on a particular solution and then
Uh,
deploy it?
the the cop out answer is I don't know.
Okay.
The easy no seriously though as we
That's a perfectly valid answer, John. There's nothing wrong with that answer at all.
it's not a complete answer, truthful, completely truthful. No, LLMs are trained. It is a neural network based system, I believe, right? So, but it's reinforcement learning. So basically you have a series of inputs, and as it regurgitates its assumptions, you give it positive reinforcements saying that's actually good or that's bad. So the positive reinforcements is basically saying that is a good I guess match of the pattern that you think that you saw. And so you do that with the text, you do that with, in this case, with multimodal, you do that also with the images and the image analyses. But I mean, that's the underlying. With LLMs, you can download these models and do additional training on them. And the way that that would work is you would spoon feed series of additional chunks of data, basically consisting of inputs and prefab outputs. So input, output, input, output. So it learns about what good results are from that input. So given this input, here's a good output. Given this input, here's a good output. I've tried to do that myself, ended up not really taking enough time to make it work well. And so I can't really demonstrate on my side how to do that successfully. We ended up with getting some random junk from somebody else's training from, half, the other side of the internet showing up in the results because I just didn't take the time to do a full set of training. But that is roughly how that works.
Okay.
It goes
It
back.
takes a huge amount of training data.
Yeah, no, I'm quite interested. And hopefully I'll be able to provide an answer at some point because I got to figure this out.
Well, okay. So another detail that you can eliminate that is spoon feeding training before handing it off to the user. And so you end up with, when you're working with an LLM, you can have like a system prompt that pre trains the LLM about the context of this user's interaction. I believe I did that a year ago. I certainly, with the chatbot system I was trying to work on recently before they bought us out and they dumped the product I was working on, was leveraging this approach and coupling it with what you might have all heard of the term RAG documents. That's retrieval augmented generation, RAG. And the way that that works is as the user inputs something, the context of what they inputted, like basically keywords, the utterance is mapped to an intent. And from that intent, you can go fetch documents that can then be used spoon-fed as system messages. And so the system messages pre-train the LLM information context so that it can give a valid answer to the user. So this is really, really useful for like an information database where the LLM might have a moderately limited context window, but you have like gigabytes of data stored somewhere. If those gigabytes of data stored somewhere are stored off and partitioned off as RAG documents so that you can query for them, then as a user asks a question, those RAG documents are fetched, spoon-fed, and then the LLM says, oh, I've got this information here, and then spoon-fed the user's prompt. And then the user says, or then the LLM says, okay, well, I have that information, and that's the detail that the user's asking about, and that too. So now here's the valid answer based on the information that I have. And it's actually very effective. It's simple. I don't know what you would term it. It's simple LLM science or application of business applications. Goes back to where I'm kind of frustrated with the company that bought us out. They're Python spoon feeding these LLM instructions. I'm like, guys, just use RAG documents. Use it, infer the intent, find a RAG document that trains the model, that provides real data, and then maybe, have a follow-up LLM query to just evaluate against hallucinations. But anyway, so yeah, again, so RAG documents is the simpler form of workarounds to not having a pre-trained model that you trained extensively your own way. Is doing ad hoc on the fly training as an extension to the user's an augmentation to the user's input. I would assume that would help you, and then you can get your creative juices flowing and kind of architect lots of variations and ways that you can have your use case. Let's say you have a physical environment or specifications that you want to spoon feed about the current state of things, and you can spoon feed that in without exposing that to the user. That's the way that you would leverage LLMs if you wanted to use it for automation of an environment. Okay, so I hope that answers that question. So like there's multiple models you can download. They do fit on these, like a 48 gigabyte Mac. These small models are really getting bigger to be able to be supported on 48 on like I just showed you guys that the Gemma was 12B and it's pretty decent. There's also thinking models, and I can show you that as well. I did want to talk about MCP as well, so maybe we will be using it that time. I was worried about not being able to use at the time, but yeah. So if I just switch over to, I love it when I'm able to keep talking.
Yeah.
Because yeah,
You're in the groove, man.
So if I switch over to Quinn 3, yeah, that's loaded. Hi, hello, tell me about robotics. Just random thing. This one is a thinking model, and so what's going to happen? Most of you guys know what a thinking model is, but what's happening is it knows to use chain of thought thinking before actually outputting. And so like it wants to, if I expand this, I gotta wait for it to finish, I guess. But you saw at first, it was starting to think about how to respond before it actually responded. And the benefit of that is it dramatically increases the accuracy of the result. So if you have time is something that is freely available, then it can really just it's basically, think of it like a pondering process, and it'll kind of output scenario and possibilities, and just again it ponders on the details of and it kind of self-reflects on itself as well. Like you can see the way it thinks. Okay, the user said, hi, hello, tell me about robotics. I need to explain what robotics is. Let me start by defining it. Scrolling, going down a little bit. Applications are a big part too. Industrial automation, healthcare. Wait, should I mention challenges in robotics? Like complexity of designing adaptable robots? See, I should structure it in a clear way. Definition, components, blah, blah, blah. So it dramatically improves the response if you have the time. It's a really, really good approach. And this is, again, this goes back to like year-old tech, but it's these thinking models don't really grow the model size that much. In fact, it actually, in some cases, shrinks the model because it's able to achieve more with less training. And so like N3 is nice and tiny relative to what GPT would do if it was going to be trying to do the same thing without being a thinking model. In fact, that's why DeepSeek came out, which is built on Quen, I believe is built on Quen. It got OpenAI in big trouble. Like OpenAI's stock went like it crashed for a little while because DeepSeek came out, and what happened was it's so ridiculously smart and is built on such a fine-tuned, um, condensed, what's called quantized model of data, or a subset of training data, that it didn't really take much time at all for them to train it. It didn't take much electricity or GPU time to train it, and they output it without much cost. So it's like, everybody was like, why are we paying, investing in OpenAI if they're, for all the training the efforts they're doing, if China's outputting this for cheap and it's doing better, right? So just to think about the science behind that, the computing science behind that, these little models are downloadable. You can run them on your machine. Now, it is true, DeepSeek is a hacking website. They'll track you and do malicious things if you go to DeepSeek's website, China, man. Anyway, so I'm not racist, just so you know, that's just what they do. And but if you download the model, it's offline. So there's a big difference between downloading DeepSeek and using the model versus going to like deepseek.com, whatever. Okay, so I just want to make sure that clarify. So yeah. So that's where I was getting at. You can watch AI think out loud. We just talked about that. It's really neat to see it thinking through that. You can, because when I'm coding with Windsurf, I can see it thinking, and before it even outputs, I'm able to stop it and say, oh, by the way, I realize I missed something because it's analyzing my user input, my prompt, and I realize I missed a detail. So it's really helpful. Okay, let's talk about MCP. So again, most of you guys are on the ball on everything, but if you don't know about MCP, you need to know about MCP, because now MCP is an example of where LLM can interface. So normally LLMs, it's got text input, text output, or maybe image input, text output, right? I mean, that's what we've seen so far. But with MCP, what you're doing is you're saying, I give you permission to invoke an API, whatever that is. Have fun. And obviously so MCP server can be a console app, right? And the console app can be connected to hardware. So now you have, say, MCP, do an MCP call to go fetch my environment conditions. Now do an MCP call to turn the robot into its different orientation. So yeah, so MCP, and like really MCP is more about like it's being leveraged on the internet. So like the original use case practical was, OpenAI or Claude being able to go do a web search. So, well, I mean, so let me back up. So LLMs, almost all LLMs have inherent support for function calling. And so function calling is basically saying, and before I come back to it with a response, I want to run a function. but it comes back to the client that is invoking it as a user, right? Saying, I want to run this tool. So you're hosting it, but I want to run it. So in other words, like LM Studio in this case is the client. So if I was going to have I could set up functions to just execute. And really what that means is I could write I could have some sort of webhook or a handle or whatever to process that. But it's really coming back to the same original software client that was invoking the LLM to begin with, or I should say the LLM host, or in this case, because it's hosting the LLM. But if I'm working with like GPT, then it could come back either to an HTTP webhook, or it could come back with saying, I just want to call you this function that you told me about. And then I would have to write code to handle that response, and as opposed to handling an assistant response as text, right? So let's put it another way. An LLM normally comes back as like receives a user message, outputs assistant message, receives a user input message, outputs assistant message. In the case of tool calling, receives a user input message, outputs a tool call message. Tool call, so then, you would then push back a tool result, and it would process that and then come back with an assistant message. So that's the way the flow would work. And it can make multiple exchanges that way. So that's before MCP. With MCP, now we can say, I want to, on my own, just go and invoke these APIs that you told me about, that you give me permission to invoke. And these APIs are, typically going to be like they could be console apps. If they're out on the internet, they're going to go through a console app. So it's going to be like it's going to be what do you call it? What's the word? It's not socket, but what's the word? Anyway, I know what I mean.
Anybody else?
It's a what do you call it? Something IO, but anyway, it's basically.
Are you talking about a protocol?
Well, I'm talking about it's basically your not console IO, but yeah, you're making a lot of noise that comes
like
through.
A stream or a socket or a
Like those, but I'm talking about like a system for the actual operating system. So, but it's a common term that coders would refer to, but it's going through your system IO. In other words, like your console app. So that's the way it works, and it's very powerful. Potentially gives you flexibility. I had hoped to demo that, and one I actually was going to try to do last night, and if I had been lucky, um, I I wasn't lucky, but if I had been lucky, I was going to do a like a windsurf like a vibe coded 3D app where I could have this like almost like a game type thing where I could push a robot around this 3D space, and but then use text to tell it to move. And the text would actually be processing through an LLM, which would then call MCP and have it move. But what happened obviously is it's hit and miss kind of thing with windsurf, trying to do vibe coding, especially on something complex like a robot simulator or a 3D environment simulator. So I end up with a blank screen before it was like a misoriented, miscalibrated thing. So I had this field of trees, whatever, but it was kind of cool idea. You guys could probably pull something off if you really put the effort in. But the point of the idea is you build, yeah.
He's got a,
So
let's see, it's a GitHub reference there. Is this the MCP you're talking about? GitHub?
yes, yes, that is the MCP I'm talking about. The GitHub reference. That's the spec. Yeah, so you can build your own. There's actually a big ecosystem. Actually, so here's another thing: is when ChatGPT took off, it became the fastest growing software the world has ever seen in the entirety of history. With MCP, I don't know what the stats are, but it blew my mind how fast the ecosystem blew up, because now everybody wants to expose their services, paid services, to Claude, to OpenAI, to whoever. And if you go to if you go to Claude's website, Anthropic's website for Claude, you can right off the bat, like it's now on the user input, you can say, I want to connect an MCP server. But when you're hosting locally, then it becomes an opportunity to actually interact with something that you're hosting on your machine. So, like I said, this is the part where I was very sad that I wasn't able to demo. But I will say this, in LM Studio, just so you know, like you can use, here's an MCP called sequential thinking. How would I tell the dog not to do that? Use sequential. I don't know what's going to happen here, to be honest with you. I don't want this rag v1, but yeah. So there's what I did was on any of these LLM hosts, you can set up a MCP servers JSON. And so when you're running an LLM locally or running Cursor or Windsurf or whatever, you can set up your MCP servers. In this case, is NPX, so it's going to run a node to host this sequential thinking. What that's going to do is it's either going to run it locally or it's going to proxy that out to a server. I don't remember if that's actually proxied out or not, but it's locally hosted as a node Node.js thing with this npx thing going on. So if I run this, you might be able to see it. We'll see what happens here using sequential thinking. I use sequential thinking when I do use Cursor, and that's basically interacting to it augments the behavior of the LLM's ability to think. Yeah, I did not see it leveraging that MCP. So that's okay though. Maybe it's possible that it doesn't show it in LM Studio that it leveraged it, but with Windsurf and with Cursor, or with Windsurf or with Cursor, I think one leaves it out. You can see it actually leveraging the MCP server if you used it there. But yeah, so what I was hoping to do was demonstrate actually having a use case, like a kind of a 3D simulator. I type in something into LLM and watch it kind of move things around. And then even the next level would be have the LLM, like go into a loop where the LLM uses MCP to query the virtual environment, look around, and basically navigate a maze or something like that all through LLM. How cool that would be. That would take a few weeks of development. I didn't have I'm sorry guys, I did not prepare. So but I hope you guys, I'm hoping I'm whetting your appetite on where this is going, how practical LLM hosting and for that matter, this LS, whatever that new thing that's not LLM, that new model is, and some of these other tools are gonna be for doing autonomy with robotics, with or just disconnected computing systems.
James got another question.
Yeah.
Go ahead, James.
So I just wanted, I don't know if you guys were distracted, John, you and Steve, or if you noticed that demo that I was giving earlier, but that is exactly what I was talking about doing with that, where the LLM kind of gets its feet held to the fire, or the traditional AI, or just a simulated robot or a real robot holds the LLM to a particular task and has this kind of a feedback loop where the output of the LLM is then tested, and then if it doesn't work, you provide some kind of feedback back to it. And thanks for sharing about this model context protocol, because I didn't know that kind of existed. That's what I was asking about, and so your talk was right on the ball for me. Thanks.
Cool.
Or your talk is right on the ball. I didn't mean to assume it was over.
That's impressive, James, because what I was trying to tell my brother here, is my friend here, is You know, I am completely out of sorts with having you do this earlier presentation, and if you present, this is like one of those cases where I might actually want to tune in and not be a presenter, but just tune in because it's very interesting what you're doing there. So I'm glad that I was able to actually go back at you a little bit.
So we're almost at the top of the hour, so you gotta, if you want to keep going a little bit, open it up maybe for a couple of questions.
I'm pretty much. Let me double check on my if there's anything else real quick.
Okay. So I think he's probably, sounds like it. John's pretty well presented what he had in mind here. Is anybody got any questions?
Well, the only thing I want to say is I just want to ask whether or not you're interested in collaborating on things outside. So look, there's a lot of people who just want to work on their own thing in their garage, and they're really not interested in working with other people. And that's great. That's fine. That's perfectly okay. I don't work well that way. I'm really only interested in doing collaborations with people and working with other people. And it seems like it's really difficult to find people who want to do that. So I don't have any expectation, but if you are interested in collaborating on that sort of thing, it's definitely an interest of mine. And I'd love to set up a meeting and talk later on about it.
That sounds good. Yeah. I mean, you know, I've got other things going on, but this is obviously, this is very fascinating to me. Like, and I enjoy this, and I would love to spend hours on this. Continue, as shown by the fact that I prepared so well.
Hey, you filled the time.
I dropped my email in the chat if you want to email me and set something
Okay.
up.
Yeah, and I'm at available at JON@JONDavis.net. So just say that as a verbal.
Okay. All right, cool. Well, anybody else? All right. Let's see. Well, I don't have any anything more. Why don't you go ahead and
Stop sharing.
Stop sharing
Okay.
there.
Thank you, guys.
Yeah. Yeah, thank you, John, for doing this. I think it, you know, he definitely struck some chords with some of these guys, so appreciate that.
If you want to unmute, and then I will mute.
All right.
Yeah. Hang on. Let's get that back up.
Switching speakers here. Okay, how are we doing here? Let's see, you're completely... Okay, there I am. All right, well, thank you so much for, John, thank you for doing this. I realize that you were fatigued coming into this, but obviously when you get on a subject that you're passionate about, it definitely...
adrenaline.
It energizes you, yes. So this was really fun. I know I learned a lot. I hope this has been beneficial to all you guys. So thank you again for coming. And any other parting comments from anybody out there on the web?
Nope. Thanks so much. Very cool.
Yeah.
Yes, thank you. I was wondering with your comment about, I mean, it seems like we had a discussion a year and a half ago about AI and ChatGPT and coding examples that people had tried to prompt out of it, and they weren't very good. And now you're basically saying that now it's writing code that you just have to evaluate. You're not really having to correct it very much. And I'm kind of stunned at that amount of progress in just a year. Where do you see the direction of AI going and the application of people still doing coding or not, as the case may be?
Yeah. So as I've been telling people, like, I no longer originate my own code. Now my mode is command and control. And I still have my experience, and it's not that, like, AI at this point has scoured the entire internet, and I am, like, my experience from a general software standpoint is not that special. What makes me valuable is my understanding contextually to the people that I'm working with and the culture that I'm working with. And so I'm able to still bring value as a software developer by understanding the requirements and kind of spoon feeding them into where the needs are and monitoring the results. So then at that point, AI is like I'm managing it as a worker and studying it as its lead. It's a very different approach to writing software than before, but it's still effective. Junior developers are going to have a hard time at this point getting into the career path of software development, though, because they're competing against machines that can do better than them. Better than me.
Stupid geniuses, as you called them earlier.
I thought that was a pretty good description of stupid genius. I think that the comment about junior AI developers having a hard time breaking in, it's true if you think about them trying to break into the sort of jobs that we broke into as developers, right? But it's easier for them to break into jobs developing things, right? Like, so I mean, what I'm telling a lot of kids is like, don't spend all your time, like necessarily like learning the syntax of a language or whatever. You need to learn stuff in order to understand how things hook together and what the context is. But the better thing to do is to just start building projects, just start doing stuff and use the AI to help you out, and use the existing modules that are available, and grab stuff off the shelf, get cheap electronics from China, assuming the tariffs don't kill that, and start putting it together and see what works, and you'll break into a job by showing that you can make use of the existing technology, which, when you think about it, that's all we did, right? I mean, we broke into those jobs by showing that we could use the technology that existed at the time that we broke into those jobs. So nothing has changed. It's just everything has changed.
Yeah. Well, what I would argue is, don't be a software developer for the sake of being a software developer. You're not going to be a hired tool.
Right. Yes, 100%.
And for that matter, lean away from the direction of a W-2 employee mindset. Get in the direction of leveraging software to be an entrepreneur and innovator.
You just said what I was trying to say better than I said it. That's exactly the point. Build your own projects, try to do things. The future is in everybody having robots that grow their food and weave their clothes and print their houses and all of that.
That's true. Yeah.
I mean, that's still science fiction, basically, but that's the direction we're headed in, right?
Have you seen the house 3D printers?
Mm-hmm.
Like full-blown
Funny you should ask that.
Yes.
I actually made the motion electronics for the very first cement house printer in the United States. So that's my number one claim to fame. So you've tripped over my massive ego.
Hey, I'll come at you. I seeded the idea of Windows PowerShell, and I can tell you about that some other year.
So wait, we're two guys who have completely changed the world and made $0 out of it.
That's right.
Oh. All right. Well, hey, this has been great fun. This has been a fun meeting. I hope all of you are doing well out there and have a great month here, and we'll be seeing you again in about 4 weeks or 5 weeks, depending on how far it is to the third Saturday of August. So let's see. Was there any questions on the chat that we didn't grab? Training. I think we got everything that was on there. Yeah, I don't see anything hiding out there. Okay. Well, anyway, great meeting. Thank you all for coming. Thank you again to Jon. And
Yes.
you guys all have a good day, good week, good month.
Thank you.
Yeah.
Thank you, Jon. I appreciate it. As I said, I thought it was a great talk. I'd like to see more in the future that's like more directly related to robotics, like that demo that you're talking about. I think that would be a cool follow.
I would love to present that sometime and or actually make that happen. So maybe that'll be my new pet project.
All right. All right. Thank you all.
Thanks, folks.
Yep.
Thank you.